Hello, and welcome back to Batch Math, where today we are going to continue building upon what we've learned about finding trig inverses on the unit circle. Now, you'll see some artifacts from the last video. I'm just going to leave those there. Notice this was number 1 we did in the last video. You can look at that work. I am going to go ahead and skip on down to the cosine section in this video and look at number 5 and see how we are going to solve it as well. So we are given that cosine inverse of 1/2, and we are asked to find the output that goes with this. Now we've got to be careful. We're dealing with inverses. If in the last video, or in the first video in this little series that I'm putting out, you'll notice that in regular trig functions, we input a theta and we output a side length or a ratio of side lengths if we're dealing with tangent. Over here, inverses, that domain and range flip-flop, all right? So theta is no longer our input. Theta is going to be our output. I like to write this here. Why? You'll see in a minute. I'm a very visual thinker. I cannot see these things in my head very well. I'm not going to lie. I like to write things down. When I'm dealing with this problem, before I start, I need to make sure that 1/2 is in the domain of cosine inverse. So we're going to come over here, cosine inverse, our domain, and I'll let me keep my shading the same in our videos. It happens to be the same domain as sine inverse, and that is between -1 and 1. Well, is 1/2 between -1 and 1? It is. Therefore, our first step, which I didn't finish our steps in the last video, is the input given in the inverses domain. Now, building on the steps that I started in the last video, my attention span sometimes, it's a good, this is a good example of going back and rereading your work. I finished that video without rereading to make sure I finished all my steps, but since I'm publishing these all together, and this is what I do with my students, I have them discover the steps and build them as we go with each problem, and sometimes they are not exactly clear and about how to build that until there's a couple repetitions. So I love it because it actually mimics how we build these steps together in our lessons. Now, off from that tangent, I'm stuck on that pun today. So 1/2 is in our domain. We have to remember we're outputting a theta that is our in our traditional trig functions. I think in terms of those better. I recognize you don't have to do this. You don't have to think in these terms. That is okay. This is purely a me thing. And look at me getting ready to write sine there because I can't talk and write at the same time. So know that what we do to one side of the equation, if we do the exact same thing to the other, we retain the original value of the equation. So if we take the cosine of or the cosine of cosine inverse of 1/2, we have to come over here and take the cosine of theta as well. And you may be asking, like, why the variable we're trying to solve for, we're moving into a function rather than out. That's actually opposite of our intuition. But it puts this in terms of something you're used to seeing. You're used to seeing some theta being input and cosine output of x on the unit circle. And you're like, oh yeah, I remember the cosine output of x on the unit circle. So I'm going to go ahead and erase the artifacts that in our last circle. And we're like, okay, from our last video. We're like, okay, on the unit circle, cosine is 1/2 here, and cosine is 1/2 here. We got 2 potential inputs for cosine. Well, we got to remember that we may be thinking in terms of sine now, but we started with sine inverse, and we are restricted on sine inverse's range, what potential outputs we can have. So if your output, that when you plug that theta into your cosine, if that output is not between 0 and pi, we can't use it. So even though cosine produces 1/2 in quadrants 1 and 4 here, because we are restricted starting at 0, theta of 0 there, we are restricted from theta of 0 all the way over to pi. That's here. Anything not in those two quadrants we can't use. In other words, we cannot use quadrants 3 and quadrants 4. We can only use quadrants 1 and quadrants 2. Well, in this case, x's are negative in quadrants 2, so it doesn't matter. We weren't given a negative 1/2. We were given a positive 1/2. I'm like, okay, that narrows things down. The angle that goes with the output of 1/2 is pi over 3. So even though we moved that to the inside, that was so we could see we're getting a theta and outputting a side length next there. And the theta that goes with that x, but restricted by the range of our cosine inverse is, and I can't remember these things without looking at them, pi over 3. I'm going to use radians. So pi over 3. All right. Now, before we leave this video, let's go ahead and talk about those other steps that we did. What did we do after we checked to make sure the input was in the domain of the inverse? Well, then we looked at now this one's optional. This is an optional step. If you have trouble thinking in reverse like I do, we can think in the original trig function. So we can apply the original, or we can convert. We can convert to original trig function in order to visualize better. This is not required. If you can think in terms of they're giving me a side length or ratio of side lengths and asking me to find a theta that goes with it, then more power to you. I just like to write it down. That's my preference. Now, option 2, or step 2, not optional, after that is that once we have that converted and we're thinking like, okay, I'm going to find that theta, we've got to consider the restrictions on that theta. So consider the restrictions on theta, or our output of our trig function. That's the output of the inverse, I said that wrong, inverse trig function. Output of their inverse trig function. And so for cosine, that's where we went, oh, our outputs for cosine inverse are restricted between 0 and pi. So if we were trying to find the angle that goes with that 1/2, that's what restricted us to quadrants 1 and quadrants 2. Then after we did that, we are going to find, if we're dealing with x, y, or y over x for tangent, we are going to find the side length. Find the side length, or ratio of side lengths, if dealing with theta. I'll put side lengths. You know what I mean. So find the side lengths that, and I'll put that as potential lengths, side lengths that go with, find the side lengths on the unit circle. Then find the theta that correlates with that side length. So that being said, we find the side length on the unit circle. That's where we went, oh, x. All right, x is what gives us for cosine. And remember, x is going to be your base. All right, so our x is our 1/2, but we were restricted based on the range because we were dealing with inverses, and that meant that this 1/2 in quadrant 4, we could not use it. That cannot go with that 1/2 because it's not an output for our inverse. But pi over 3 did go with that 1/2, and that's why that's the solution. So you find the theta that correlates with the given side length on the unit circle. And if it's tangent, it's ratio of side lengths, and you're getting ready to see me deal with that in the next video. So as I finish up typing this, because we all know that I am part of the spell check generation. I'll just get close enough and then let spell check get it from there. Find the theta that correlates with the sine length on the unit circle, and we have our steps list completed. And that's usually how it goes. We do a couple of problems, and each time the student builds their understanding, and we will build that series of steps. And by the time we get to, problem 3 or 4, they created the list of steps for themselves. And that's what's awesome about exploratory learning, where I just ask guided questions. You slowly build this for yourself. So if you want to see how I built these steps, please see my prior video over sine, and that's where I was explaining how step 1 comes into play. And then as we worked through cosine, I clarified those other steps that I used in the sine video. So thank you so much for your time. Please look for my tangent video, our tangent inverse video coming up next.